Hello and welcome to Awesome Day 2024. My name is Peter and I will be your AWS technical trainer for this next session, which is an introduction to AWS services, compute, storage, and databases. In this module, I will walk you through the foundations of compute, storage, and database services, which make up the basic services in the cloud. These are some of the services you might be using to deploy new workloads in the cloud. In the first section of this module, we will talk about compute. AWS offers three types of compute options at the foundational level: virtual machines, containers, and serverless. So let's first discuss virtual machines, or the Amazon EC2 service, which stands for Elastic Compute Cloud. You can think of Amazon EC2 as a virtual machine which is used to run your applications. It has the word elastic in it because it is very flexible. It allows you to change the compute capacity by resizing it. It gives you complete control over your server and how you want to manage it, who has the permission to use it, what security controls you want to put in place, etc. Deploying an EC2 instance happens within minutes. This greatly reduces the time required to boot up your new servers. EC2 supports Linux, Windows, and macOS in some selected regions. Just like an on-premises server, our virtual machine will have a specific compute capacity, expressed in virtual CPUs, a certain amount of memory, a network capacity, and connected storage. EC2 can solve a lot of problems that are more difficult to solve with an on-prem server. They are called disposable resources because we can spin them up within minutes and dispose of them when no longer required. For example, when we set up a workload in the cloud, there are certain data-driven decisions. Let's say, for example, how many instances do we need? We can use data from our monitoring services to determine exactly how much compute we need. Consider a situation where you need a virtual machine just to prepare a proof of concept, or POC, to show how an application might work and then terminate it after it has been done. In an on-premise environment, if I purchased the server just for the sake of a proof of concept and never touched it after that, my manager is probably not going to be very happy with me. EC2, on the other hand, is a great solution because you can run the resource for as long as you need it and terminate it at any point in time. This is what we mean with quick iterations. And for that same reason, if we do make a mistake of, for example, over-provisioning or under-provisioning, we can fix it really fast. Now that we know what EC2 is, what are some of the distinct benefits? Let's start with elasticity, the ability to scale your application as demand changes. With EC2, there's various different features built in that give us the ability to scale up or down, also referred to as vertical scaling, or in or out, which is called horizontal scaling. For vertical scaling, we can change the underlying instance type. For example, move to a larger or smaller instance type. Horizontal scaling means that we are changing the number of EC2 instances. For example, let's say you're running a web server. Under normal load, you expect there to be, let's say, 100 users connected to your application around 12 p.m. But what happens if we go above the number we were expecting? We have the ability to increase the number of instances that serve the web traffic, or move to a larger instance type. We can go up to 200 or 300 or even 3,000 concurrent users if needs be. by simply increasing the number of resources under the hood. This way, we pay only for the resources that we actually use. Now, the second one here is control. We have the ability to stop and start instances or reboot or even terminate as we need. Just like with elasticity, this potentially helps to save cost. When we don't need our instances to be running, we scale down. But then it also gives us the ability to size our fleet appropriately to the amount of traffic. So EC2 gives you the flexibility to choose what you want when you need it. There are a number of different EC2 instance types and families we'll talk about in a moment here. But you can pick the right type of instance for the right type of job. EC2 is also integrated with other services, like the Elastic Load Balancer, which enables you to create a secure, scalable, and highly customizable architecture. There are a number of additional benefits to EC2, such as reliability and security, which we'll touch more on later. It's inexpensive, as you can pick the right type of instance for the job, whether it's a small or a large instance, to match the appropriate workload. When deploying an EC2, you make a choice about both the hardware you're going to run your virtual machine on, which we'll discuss in the next slide, and the software. For the latter, you must specify the Amazon Machine Image, or AMI. An AMI provides the information required to launch an instance, such as the operating system of choice, storage volumes, launch permissions, and block device mapping. You could also have custom applications pre-installed to speed up deployment time. One source to get customized AMIs is the AWS Marketplace, where you can purchase Amazon Machine Images from trusted partners. Once an EC2 instance is launched, it can also be temporarily stopped or even terminated altogether. EC2 is what you make it. It could be a web server, or an application server, or a database server, and so on. Thinking of EC2 as disposable allows you to take advantage of pay-as-you-go pricing, significantly reducing your overall cost. Now, there are a large number of EC2 instance types, which is great because it allows you to deploy the EC2 instance that will be the most efficient and effective for your workload. The instance types are grouped into instance families, which make it easier to understand what each type is best used for, allowing you to make an informed decision. You want to reduce the overall cost of your application? Well, choose a general purpose instance, just like the T4G or the M7G. Need more compute capacity to help processing application requests or batch processes quickly? Choose a compute-optimized instance, just like the C7G, for example. Need more memory to help speed up your database? No worries. Choose a memory-optimized instance like the R7G or the X2. What if you're interested in machine learning, 3D modeling, or inference? Choose an accelerated computing instance like the powerful P5 or G6, or what about our in-house Trainium processors? Each instance type also comes in different sizes, allowing you to be as cost-effective as possible, while still getting your work done. We previously learned that flexibility was a great benefit of EC2, and pricing flexibility is no different. With multiple purchasing models to fit your workload, we give you the options to make the decisions and configuration that is right for you. With on-demand, you have the greatest flexibility and control over when and how you configure and deploy your instances. This is great for spiky workloads, unpredictable workloads, temporary workloads, or workloads that cannot be interrupted, but only run for a short time. Saving plans give you a significant price reduction compared to on-demand for workloads that run permanently. You can commit to a certain amount of capacity that you're going to utilize over time. For example, you can choose a 1 or 3 year commitment, and the more upfront payment you make, the bigger of a discount you'll get. It's great for steady state workloads, your public-facing website, for example. Saving plans is a very flexible pricing model where your commitment can be for EC2 instances of different types, but even for other compute services like Lambda and Fargate. And then lastly, we've got spot instances, which gives you up to 90% off of the on-demand price, with one caveat though. Spot instances pricing isn't fixed and is based on supply and demand. So if the demand for EC2 instances rises, there is a chance that the spot instances can be taken away with a 2 minutes notification period. So in other words, spot instances are not guaranteed to run permanently. This means you need to be strategic about how you deploy them. However, they are great for an ultimate cost reduction. As an example, most stateless applications can use spot instances and benefit from the lower cost. Now finally, EC2 instances support per second billing with Amazon Linux, Windows and Ubuntu, and a per hour billing with all other operating systems. This leads to a granular billing, which is great for cost management. Another concept that I want to introduce here is the concept of unmanaged versus managed services. With unmanaged, you need to manage the scaling, the fault tolerance, and availability on your own within your application or architecture. Keep in mind that if you were running this application on premises, you'd be managing this anyway, including managing the physical infrastructure. But one of the key advantages to some of the services we're going to talk about is that there is actually a managed, or in some cases, fully managed option, where you don't have to worry about the scaling, the fault tolerance, and the availability, which are built in to that service. Next, we will talk about serverless, and we will do that by comparing EC2 to serverless. Now, EC2 is great. It is extremely powerful, configurable, flexible, and gives you control over your application and how it runs. But as we all know, with great power comes great responsibility. You must manage fault tolerance, high availability, scalability, the operating system and application patches, access, permissions. It is a full-time job. Now, how does this compare to serverless? The idea of serverless came about when we thought, what is the most important thing for our customers? Customers just want to be able to run their code and not have to worry about the administrative side that's required to run the code. When we use the word serverless, this does not mean there are no servers. This simply means you aren't responsible to provision or manage these servers. You can just focus on your application and leave the heavy lifting to AWS. Serverless services automatically scale to meet the demand for your application. This way, you will never pay for idle resources. Compared to EC2 instances, where it is likely that you are not using 100% of the compute capacity at all times. However, you would still need to pay for the EC2 instance even when it is idle and waiting for traffic. With serverless computing, such as Lambda, you pay per request and the time the Lambda function is actually running. Serverless services have built-in high availability and fault tolerance. So now that we've talked about what serverless is, let's talk about an amazing serverless compute service called AWS Lambda. AWS Lambda is a fully managed compute service which runs stateless code. Previously, we talked about EC2 instances, which required us to choose the right type of instance to run our application. With Lambda, we just need to add our code to something called a Lambda function. Then tell it when to run, typically based on an event. The Lambda function's code runs in a runtime environment, and you can set up an environment based on one of a very long list of programming languages that you can choose from. You could even create your own custom runtime. Lambda is an event-driven architecture, which means it is triggered or executed in response to events. Or you could also run it on a schedule. Lambda gives us some great benefits. Lambda manages the execution and completion of the code. You don't have to worry about deploying infrastructure or anything. Be aware that a Lambda function can only run for a maximum of 15 minutes though. For code that runs long-term, you'll want to stick with something like EC2. AWS Lambda excels at executing short-running, stateless code that has a defined start and finish, ideal for microservices. AWS Lambda also helps us to add automation into an environment. Whether it is automatic logging, response and remediation, incident management, analysis, etc. The list goes on and on. Now let's look at a demo on Lambda using the console. I will create a Lambda function which is going to help me stop my EC2 instance. I have this EC2 instance in the running state. So let's see how we can stop this using some script in the Lambda function. I will type in Lambda into the search bar at the top. Let's click on Lambda. Next, I will click on Create Function. Here I will give the function a name. Followed by your favorite runtime. For my example, I'm going to go with Python 3.8. Next, we need to give our Lambda function permissions to actually stop EC2 instances. To do this, we will choose Change Default Execution Role. I will choose Use an existing role. I have created this role previously. This role allows Lambda function to make changes to our EC2 instance. Now I will click on Create Function. Scroll down and you will see Code Source. This is where you will enter your code that you want Lambda to execute. I will paste my code into this box. This code is going to look for instances which has a tag that says auto start stop equal to yes. If it finds instances with that tag and value, it will go ahead and stop these instances. I will select Deploy and next click on Test. If you're asked to create a test event here, simply give your event a name. Scroll down and click Save. Now click Test again. And there you go. It has been successfully executed. Let's go to the EC2 to check if the instance has been stopped. And yes, it has. It was only a matter of seconds for the code to stop the EC2 instance, and I didn't have to provision any server to execute the code. Because this is a demo, I executed the code manually. In the real world, you would probably create a trigger that will tell Lambda function when to execute your code. For example, you could add S3 as the trigger. we could specify that every time a new object is added into a bucket, this will trigger the Lambda function, and that's when the code will get executed. This is what we refer to as an event-driven architecture. Lambda is just one such serverless service. You can create an entire serverless application consisting of different Lambda functions and other services within AWS that will integrate with Lambda. Some use cases for serverless architectures are building web applications using static websites, or processing data at nearly any scale. Or what about automating batch processing, or indexing and storing documents and images automatically? Really, serverless can be used to power chatbots, logic, and we use serverless, for example, ourselves to power voice-enabled applications like Alexa. And it can be used for IT automation. But what if you have an application consisting of microservices that need to scale very dynamically and might run longer than the maximum runtime of Lambda? This is where containers can help out. So what are containers? Let's assume here that you are a developer who's coming up with their own piece of code, and you're working on your own application environment. You're trying everything out, you're testing it out, and when you're testing your application, everything works perfectly. So you're now ready to actually deploy it to your end customers, and for that you want to move all of that into a server. However, once you do the test there, you notice it is not working. Strange, since it was working perfectly when you tried it in your own environment. However, the runtime between our laptop, which could be, for example, Python 3.12, isn't the same as the runtime that we have installed on our server. Let's assume here Python 3.10. So how can we make sure that the runtime itself gets moved with the application code? That is where our containers comes in. So if we have a container, we'll actually make a combination of not just the code itself, which you obviously need, but also the actual runtime that we are planning to use. Assuming here Python 3.12, for example. Also, all the dependencies that we might need to run this code. And finally, any configuration that we require to run our application code. And this way, once we've developed our code inside a container, all we need to do is move the entire container to the server and everything will run smoothly. Containers can run on any operating system. And they give us a balance between the long-running compute that EC2 gives us, whilst being extremely quick to scale and run, similar to Lambda. Now in this slide, we will look at the services that are involved in deploying a container. First step, the registry. When you develop containerized applications, you build a container image that holds everything needed to run your container. As we saw in our Lightboard session, this includes the application code, the runtime, system tools, system libraries, and some settings. You push your images to a repository and pull those images from the repository when you want to actually deploy containers. The service that helps in storing your container images is called the Amazon Elastic Container Registry, or ECR. Next step is to choose your orchestration tool. When you're running a few containers, managing them isn't a deal breaker. However, when you have hundreds of containers running, you need some sort of orchestration tool that can easily deploy, manage, and scale containerized applications. There are two services that you can choose from for the orchestration services. These are Amazon Elastic Container Service, or ECS, and the other service is called the Amazon Elastic Kubernetes Service, or EKS. These services help manage the scaling, networking, and maintenance of your containers. They help you manage containers, startup and shutdown, monitor container health, deploy updates, and manage failover and recovery. Amazon EKS is a managed service that you can use to run the Kubernetes container orchestration software on AWS. It is a complex tool and is capable of performing advanced tasks. This is suitable for companies who have been using Kubernetes in their environment for quite some time. Amazon ECS is a managed container orchestration service that is suitable for customers who are new to containers and haven't had any containers running in their company. It is much simpler to use when compared to EKS. And then finally, choose your container hosting service. You must decide which compute resource your orchestration tool will use to host your containers. You can choose the Amazon EC2 to launch containers. However, since EC2 is an unmanaged service, you need to manage the cluster yourself and all the underlying infrastructure. So there is a lot of hands-on work involved, but it also provides a lot more control. By contrast, AWS Fargate is a serverless hosting service that runs containers without the overhead of managing and scaling the underlying compute. Ideal for when you want to be less hands-on. In summary, Amazon EC2 enables you to launch as many or as few virtual servers or EC2 instances as you need, and enables us to scale up or down to handle changes in requirements or spikes in traffic. Amazon ECS is a container orchestration service that gives us the ability to manage containers at scale. And finally, AWS Lambda is a compute service that lets you run code without provisioning or managing servers. Lambda runs your code on a highly available compute infrastructure, and you will only pay for the compute time that you consume when a request is made to the Lambda function. Now let's move on to storage on AWS. We have a number of different storage options, depending on your application's needs. Amazon S3, or the Simple Storage Service, is a scalable, highly durable object storage in the cloud. We also have S3 Glacier for low-cost, highly durable archive storage in the cloud. Then we have Amazon EBS. EBS volumes are block storages connected to EC2 instances over the network. Amazon EFS is a scalable network file storage service for multiple EC2 instances. We also have Amazon FSx. Amazon FSx makes it easy and cost-effective to launch, run, and scale a future-rich, high-performing file system in the cloud. And finally, as you might recall, we talked about hybrid cloud deployments in the previous module. With Storage Gateway, we have a hybrid cloud storage service that gives you on-premises environment access to virtually unlimited cloud storage. Right, now let's dive deeper into S3. S3 is an object-level storage. It is a managed service, which means S3 manages the storage layer for you. There are two terminologies you need to understand with S3. That is objects and buckets. Now, buckets are containers that store your objects. Objects are consisting of the data in the file, a key that uniquely identifies a file, and some other metadata like timestamps and storage classes. S3 is designed for what we call 11 nines durability. Durability, by the way, is a measure of how likely you are to lose a file or object. For example, if you store 10 million objects with Amazon S3, You can, on average, expect to incur a loss of a single object once every 10,000 years. Now that's some extreme durability. There is no limit to how much data you can store in S3. You can store as many objects as you like. However, each object cannot be larger than 5 terabytes in size. We previously saw event triggers in the Lambda demo. This is a great feature of S3 as well that enables automation and designing event-driven architectures. You can also enable replication of objects between different buckets to create additional copies of that data within the same region or maybe even in a different region if you need to. Similar to our pricing models with EC2, S3 has what is called storage classes. Each storage class ranges from immediate accessibility for hot data all the way through to archival options with long access time for cold or frozen data. You can choose the storage class depending on your access patterns. Each storage class has a different pricing. The hot storage classes pricing is comparatively higher than the cold storage classes pricing. If you have any data that needs to be stored for, say, the next 7 or 10 years due to compliance reasons, S3 cold storage classes would be very cost-effective here. Similarly, S3 can be used to store big data and analytics, disaster recovery, and static website hosting. Amazon Elastic File System, or EFS, is a serverless and fully managed elastic file storage that allows you to share file data without provisioning or managing storage capacity and performance. It supports the Network File System version 4 and is used for Linux-based workloads. With Amazon EFS, you can create a file system, mount the file system on an Amazon EC2 instance, and then read and write data to and from your file system. Amazon FSx comes in various flavors, such as FSx for Lustre and FSx for Windows. Amazon FSx for Windows File Server provides a fully managed shared storage built on Microsoft Windows servers, backed by a fully native Windows file system. It is obviously used for Windows-based workloads. Amazon FSx for Lustre helps in delivering sub-millisecond latencies and high throughput. It can be used for high-speed workloads, such as machine learning, high-performance computing, or HPC, video processing, and financial modeling. The last service we'll talk about in this section is the Amazon Elastic Block Store, or EBS. EBS is a block storage that is attached to our EC2 instances over the network. This is where, for example, your operating system will be stored. It provides persistent block storage to our EC2 instances, which means the storage won't be lost even when the state of the EC2 instances change. EBS volumes can be detached from one EC2 instance and attached to another EC2 instance. It comes in a variety of different types with different underlying physical components. This allows you to apply an appropriate volume type to your workload. For example, if you are running a database that is reliant on low latency and random access, a provisioned IOPS SSD or solid state drive may be perfect. However, if you're more interested in streaming large log files, then a throughput optimized HDD or hard disk drive may be better suited. It's very easy to scale up and down the storage volume. Pricing will be calculated according to the amount of storage you have provisioned. EBS volumes also support snapshots, which are backups of your volumes. These snapshots are stored in S3 behind the scenes, so you get great availability and, remember, durability of your backups. Lastly, EBS supports at-rest encryption to keep your data secure. As we have seen, AWS provides a broad portfolio of storage solutions. We have object storage with Amazon S3 and Amazon S3 Glacier to store and retrieve any amount of data from anywhere. Amazon EFS and Amazon FSx, a fully managed, cost-effective file storage solution. And finally, Amazon Elastic Block Store, an easy-to-use, high-performance block storage for both throughput and transaction-intensive workloads at any scale. Millions of customers use AWS storage services for a variety of use cases to help transform their business, increase agility, reduce cost, and accelerate innovation. Next up, let's talk about databases. Earlier, I introduced the concept of unmanaged versus managed services. Well, here I want to talk about do-it-yourself databases versus the AWS managed databases. When we say do-it-yourself databases, we are referring to databases on EC2 instances. You can definitely run your database of choice on EC2. There are a few valid use cases for this. Maybe you feel the need for accessing the underlying operating system to install helper services, or maybe you need to use a database engine for legacy compatibility that AWS doesn't natively support. However, if you go down this path, you must manage high availability and fault tolerance, database backups, primary, secondary replication, operating system and database engine patches, etc. The administration tasks are quite extensive. Running a database on EC2 is an example of using an unmanaged service. You could instead choose to deploy your database into one of AWS's managed database services. These services provide many benefits. They are simple to set up, manage, and maintain. High availability is set up for you at a push of a button. Those services are purpose-built, which means they focus on performance. They will manage the underlying infrastructure for you. Now, in the past, we didn't have much choice when it comes to database selection. However, in the current world, there are so many to choose from. AWS has the broadest selection of purpose-built databases for all your application needs. Listed here are some examples of databases that could fill your needs. For example, we have relational databases that store data with predefined table structures and relationships between them. They are used for traditional applications such as Enterprise Resource Planning or ERP, Customer Relationship Management or CRM, and e-commerce. The AWS services for relational database are Amazon RDS or the Relational Database Service, Amazon Aurora, which is a cloud-native relational database service, and Amazon Redshift, our data warehouse. Key value databases are optimized for common access patterns, typically to store and retrieve large volumes of data. They are used for high-traffic website applications, e-commerce systems, and gaming applications. Our purpose-built service for key value database is DynamoDB. In-memory databases are used for applications that require real-time access to data. They are used for caching, session management, gaming leaderboards, and geospatial applications. We offer two services: Elasticache, which is used as a cache in conjunction with another base database, and MemoryDB, which is a fully standalone in-memory database service. Document databases are designed to store semi-structured data as JSON-like documents. They are used for content management, catalogs, and user profiles. Wide column databases use tables, rows, and columns, but unlike a relational database, the names and format of the columns can vary from row to row in the same table. Our service is called Key Spaces for Apache Cassandra. Graph databases are used for querying millions of relationships between highly connected graph datasets. And they can be supported using Amazon Neptune. Ledger databases are used to track and maintain the history of every application data change. Many customers use QLDB, or the Quantum Ledger Database Service, for these kind of workloads. And finally, time series databases are used to get insights from data that changes over time, which we can do with the TimeStream purpose-built database service. When choosing a database, previously it was always, we have a SQL-compatible database, this is what we use, so this is what we will continue to use, even if the use case didn't fit. Now with the cloud, you have a range of database options to choose from. Our first choice must be to SQL or not to SQL. SQL databases are great when needing to join tables, perform complex queries, and use legacy applications. However, NoSQL databases, on the other hand, can be extremely fast and provide low latency responses. They support simple queries and are similar to lookup tables and scale differently to a traditional SQL database. They're all about speed of access rather than complexity of query. So how do you choose? For a relational style database that has transactional requirements, look no further than Amazon Relational Database Service, or RDS. If you need a relational style database but require analytical processing, then Amazon Redshift is your service. For storing your data in a non-relational way for transactional databases, Amazon DynamoDB may be a good fit for those needs. But you might also have the need for a graph database, which is more focused on the relationship between data points rather than the data points themselves. You can use this for fraud detection or recommendation systems. Amazon Neptune has you covered there. Lastly, Amazon Elasticache provides a caching solution and is available for two popular caching engines, namely Redis and Memcached. Select the database that best suits your workload. First up, we have Amazon RDS. RDS makes it easy to set up, operate, and scale a relational database in the cloud. Being a managed service, RDS provides cost-efficient and resizable capacity and handles all the time-consuming database administration tasks. It allows you to focus on your applications. Amazon RDS supports 7 familiar database engines that you can choose from, including Amazon Aurora, which we'll talk about, Microsoft SQL Server, MariaDB, Oracle, PostgreSQL, MySQL, and DB2. Amazon RDS also provides a number of features that make it easier to manage common database tasks. Firstly, you can configure automatic backups and maintenance windows while working around your application traffic. By default, Amazon RDS enables automated backups of your database instance with a 7-day retention period. Secondly, RDS gives you the ability to run your database instance in a multi-AZ deployment, which increases fault tolerance by maintaining a synchronous replica for automatic failover. Lastly, you can scale the compute resources and storage capacity needed for your database over time as your data or demand for your database grows. We've also got Amazon Aurora, which is a MySQL and PostgreSQL compatible relational database built for the cloud. Like other high-end commercial databases out there, Aurora provides high performance and high availability, and with that comes simplicity and cost effectiveness. Aurora is up to 5 times faster than standard MySQL databases at a tenth of the cost. It's also built for durability and scalability, whilst providing multi-regional capabilities. There are also some features of Amazon Aurora that sets it apart from other relational databases. Aurora has a distributed, fault-tolerant and self-healing storage system. The data blocks are continuously scanned for issues and repaired automatically. You can have up to 15 read replicas on Amazon Aurora across multiple availability zones, which share the same underlying storage volume as the primary database instance. This helps with the scaling and high availability for your applications. There is even a serverless feature in Aurora called Amazon Aurora Serverless. It can automatically start up, shut down, and scale capacity up or down based on your application needs. This is a great option to save costs on unpredictable or very spiky workloads. Next up, we have Amazon DynamoDB, which is a fast and flexible non-relational database service for applications that need consistent single-digit millisecond latency at any scale. The fully managed nature of DynamoDB makes it really flexible for many different use cases, but also takes away a lot of the management tasks. DynamoDB handles all the partitioning of data in your tables, so you don't have to worry about managing those different partitions yourself. You also get fine-grained access control with identity and access management. DynamoDB doesn't have underlying instances. Instead, it works based on the number of read and write capacity that you provision for the table. There are actually 2 ways. You could either mention the number of read and write capacity units, or you could use the on-demand capacity option, which is suitable for spiky workloads. DynamoDB offers single-digit millisecond response times, which will be sufficient for a lot of your workloads. However, sometimes your application needs even faster response times. In these cases, we have something called the DynamoDB Accelerator, or DAX for short, which is an in-memory cache that reduces response times down to microseconds. DynamoDB has a feature called Global Tables, which automatically replicates data across multiple regions. You can perform read and write operation on any of those tables. Some use cases of DynamoDB would be for game platforms, including game state, player data, session history, and leaderboards. In summary, there are 15 databases to choose from, including relational and non-relational databases. Depending on your use case, select the database that will meet your specific needs. NoSQL databases are purpose-built for specific data models and have flexible schemas for building modern applications. If you are looking for something that requires a very good performance, no matter how many requests come through, NoSQL database is your friend. I hope you've enjoyed this session and found it interesting. We would love to hear what you thought about this session. So please take a minute to complete the survey. Your feedback is important to us and can really help us shape and improve events and learning in the future. You can also reach out to us on the various social sites listed on this slide. And why not test your knowledge? Make sure you complete the knowledge check after this session to see how you're progressing. And that brings us to the end of this module. For our next module, we will go over networking and security. Thank you.